Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about solving systems of linear equations. In this presentation, you'll learn the definition of a system of linear equations, how to determine if an ordered pair is a solution to a system of equations, and you'll learn how to solve systems of linear equations using XY tables, graphs, and a method called substitution. A system of linear equations is a set of linear equations in which the objective or goal is to find the ordered pair, if any ordered pairs exist, that make all the equations in the system true. Graphically, this would imply that when we solve a system of linear equations, we're looking for the ordered pair where the graphs intersect. If we were looking on an XY table, and looking at the XY tables for all of the linear equations in our system, then we would be looking for the ordered pair that appears in all of the XY tables. When solving systems of linear equations, we have three categories of solution possibilities. The first is no solution. If we're talking about linear equations, then the system having no solution would indicate that the graphs never intersect. So that would mean that we have parallel lines. For a system of linear equations to have the second type of solution, which is an infinite number of solutions, the two equations would have to be the exact same equation. The third type of solution that we have is one and only one solution. That is, when we have a system of linear equations, those lines will intersect in just one ordered pair. And this third type is the type that we'll focus on in this course, finding the ordered pair that a system of linear equations has as its solution. Let's see if we can determine if an ordered pair is a solution to our system. Consider the system of equations formed by the first equation, 3x plus y equals 13, and the second equation, x minus y equals 3. We'll consider if the ordered pair 4, 1 is a solution. Well, if the ordered pair 4, 1 is a solution to this system, then it should make both equations true. And so we can do a quick check here, letting x be 4 and y having the value 1. We get 3 times 4 plus 1. According to our equation, that should turn out to be 13. And 3 times 4 plus 1 is 13. So we have a true statement here. In the second equation, we'll do the same thing. Let x be 4 and y be 1. And again, according to the equation, x minus y is supposed to equal 3. And when we have these values for x and y, we do get 3. So this is also a solution to the second equation. Therefore, we can conclude that the ordered pair 4, 1 is a solution to this system of equations. We should anticipate then, if we were to graph both of these equations, that they would intersect at the ordered pair 4, 1. Let's check another ordered pair with a different set of linear equations. Excuse me. Our system of linear equations in this example will be y equals negative 3x plus 2 and 9x minus 8y equals 2. We'll check to see if the ordered pair 0, 2 is the solution to this system. Again, if this is a solution, then it should be a solution to both of these equations. When we plug in the ordered pair 0, 2 into the first equation, y equals negative 3x plus 2, we have the following. 2 is equal to negative 3 times 0 plus 2, which is a true statement. We get 2 equals 2. And so this ordered pair is a solution to the first equation. Plugging into the second equation, 0 goes in for x and 2 goes in for y. We actually get a false statement. We get 9 times 0 minus 8 times 2 excuse me, sorry, I got confused there for a second. Sorry, we get 9 times 0 minus 8 times 2, which is equal to negative 16. According to our equation, it's supposed to be equal to 2, and so this is not true. And so 0, 2 is not a solution to the second equation. Since it's not a solution to the second equation, it cannot be a solution to the system of equations. So it's a very important point here. Even though the ordered pair 0, 2 is a solution to the first equation, to be a solution to the system, it must be a solution to all the equations involved. Let's take a look at how we might use graphs to solve a system of equations. Here we have the system formed by 2x minus y equals 9 and the equation x plus 3y equals 8. If we graph both of these linear equations, we get the following graphs, represented here by the red line and the blue line. And we can see that those two graphs do intersect. They intersect here at this ordered pair. And it appears that that ordered pair is the ordered pair 5 on the x-axis and 1 on the y-axis. So the ordered pair 5, 1. And so the solution to this system is 5, 1. Another method we can use is the method of substitution. The method of substitution uses a really fundamental idea about equality, and that is that anytime we have a statement of equality, we have two equivalent names for the same quantity. So even as early as kindergarten, we actually begin facilitating this idea when we have children think of sums of numbers that equal 5. And so we make statements like 2 plus 3 is equal to 5. Well, that means anytime you have 5, you could also say 2 plus 3, and it would be the same thing. So this is the big idea that the substitution method uses. The steps here are as follows. First, we'll isolate a variable in one of the equations. Second step, we will substitute that value into the other equation in our system. Third, we'll solve the resulting equation. After step 2, we should have an equation that only has one variable. Once we solve that equation, we now have one of the two values of our variable, so we'll substitute that solution into our step 1 equation where we isolated a variable, and that'll allow us to solve for the second variable. Finally, we'll state our answer as an ordered pair. Let's see this substitution method in action. We're going to solve the system of equations formed by 2x minus y equals 9 and x plus 3y equals 8. So in step 1, we'll choose to solve for x in the equation x plus 3y equals 8. And that results in the equation x equals 8 minus 3y. In step 2, instead of using x, we will use the statement 8 minus 3y. So when we look at 2x minus y equals 9, again, instead of using an x, we're going to use the equivalent name for x that we found in step 1, which is 8 minus 3y. And from there, we're going to solve for y. So in step 3, we begin that process of solving for y. And finally, once we go through all those steps to solve this equation, we find that y is equal to 1. So now we know when these two lines intersect, the y value must be 1. So now we'll go into step 4 and we'll find the x value that's associated with a y value of 1. And you'll notice we're plugging back into the equation that we found in step 1. That is 8 minus 3y is equal to x. And since we found that y is 1, we're plugging in that value. And we find that x must be equal to 5. So now we know the solution to this system of equations is the ordered pair 5, 1. If we were to graph these two equations, we